Hello and welcome to Learn Index Properties, Relationships and Tests. This is video part 2. Myself Janet Popat. In previous video, we have seen three-phase diagram assumptions as well as three-phase diagram and two-phase diagrams. Generally, if the soil is in a natural state, it is in three phases. If it is fully dry, it will be in two phases, and if it is fully saturated, it will be in two phases. Now, let us move to index properties or basic fundamental definitions for index properties of this topic. First definition, that is void ratio. Void ratio is denoted by small e. Its equation is VV upon Vs. Here VV means volume of voids and Vs means volume of solids. So void ratio can be defined as volume of voids to volume of solids. Now void ratio generally lies in the range of 0 to greater than 1, and it is written as 0.4, 0.5, etc. Void ratio is very useful and basic unit. Let us move to second fundamental definition, that is porosity. Porosity is denoted by small n. It is defined as ratio of volume of voids to total volume. Here it is again a ratio of volume of voids to total volume, but it is generally denoted in percentages. Now value of porosity is lying between 0 to 1. It can be minimum 0 and maximum 1. Let us move further. Third definition is degree of saturation. Degree of saturation is denoted by capital S and in suffix R, SR. SR is equal to VW upon VB. Degree of saturation can be defined as ratio of volume of water to volume of voids. Here, if volume of water is sometimes 0, as it is a fully dry soil, then SR value will be 0 and vice versa. If it is fully saturated soil, then all the voids will be covered by volume of water only. So in denominator it will be VV is equal to VW. So VW will be cancelling out and SR will be 1 for fully saturated soil. Generally SR is expressed in percentage value. Let us move to fourth definition, that is air content. Air content is also shown in percentage. Air content is denoted by small a and in suffix C, AC. AC is equal to VA upon VV. VA, that is volume of air upon volume of voids. So air content can be defined as ratio of volume of air to volume of voids. Here, as degree of saturation and air content both are having same denominator as VV, we can say both are complementary to each other, and we can write that AC is equal to 1 minus SR, as they are complementary to each other. Let us move forward. Next definition, that is percentage air void. As the name suggests, it is represented in percentage value. It is denoted by NA. Here it is written as NA is equal to VA upon V. VA means volume of air and V means total volume. So percentage air void can be defined as ratio of volume of air to total volume. Here for fully dry soils, I mean when the soil is fully dry, it will be having total voids as volume of air. So there will be Na is equal to N, and N is equal to porosity. If the soil is fully saturated, there will be no air and Va will be 0. So Na will be 0 there whenever fully saturated soil is there. Next definition, that is water content. It is also shown in percentage value. Water content is denoted by small w. It is defined as weight of water to weight of dry soil. Or in some literature, in some books, in some materials, it is also defined as ratio of mass of water to mass of dry soil. Ultimately, both will be the same. As it is written in percentage value, it is multiplied into 100. Moving forward to the next definition, that is specific gravity. It is denoted by capital G. G is equal to Ws upon WW. Ws means weight of solids and WW means weight of water. Specific gravity G can be defined as weight of soil solids of a given volume to the weight of distilled water of a same volume, and it is also denoted by gamma S upon gamma W. Specific gravity is unitless quantity. It is written as like 2.5, 2.7, etc. Specific gravity is further divided in two types, that is absolute specific gravity and mass specific gravity. Here we are understanding specific gravity, that is absolute specific gravity, and next type, mass specific gravity, is denoted as G and in suffix m, Gm. If you are taking bulk unit weight instead of solid unit weight, it is mass specific gravity. Generally, in rocks and stones, specific gravity is the main property to define and to differentiate them. Let us move to next definition, that is unit weight of solids. Unit weight of solids is denoted as gamma. Here gamma is equal to Ws upon Vs. Ws, that is weight of solids upon volume of solids. Moving to the next definition, and the next definition, that is bulk unit weight. Bulk unit weight is denoted by gamma B is equal to capital W upon capital V. Here capital W, that is total weight of total soil mass, and capital V means total volume of total soil mass. Here next definition, that is dry unit weight, that is denoted by gamma D. Gamma D is equal to capital WD upon capital V. WD means weight of dry soil solids and V, that is volume. So dry unit weight can be defined as ratio of weight of dry soil to total volume. Generally, all the unit weights are having unit kilonewton per meter cube. Let us move to the next definition. Saturated unit weight. Saturated unit weight is denoted as gamma sat or gamma saturated is equal to W sat upon capital V. W sat means weight of saturated soil mass and V means total volume. Hence, it can be defined as ratio of saturated weight of saturated soil mass to the volume of total soil mass. Next definition, that is submerged unit weight. Here we know the meaning of saturated soil mass, that is full of water and there is no air. But submerged soil mass, that is not full of water but it is partially saturated. So we can write submerged unit weight as gamma SUB submerged is equal to W sub upon capital V. W sub is equal to weight of submerged dry soil solids upon total volume. Here units of these unit weights are also kilonewton per meter cube. Submerged unit weight can further be written as gamma dash is equal to gamma saturated minus gamma W. So gamma submerged can be written as gamma dash also. And to find unit weight which is submerged, we can calculate this as by deducting unit weight of water from saturated unit weight. Next definition, that is bulk density. Bulk density is denoted as rho B. Rho B is equal to capital M, that is total soil mass, and capital V, that is total volume. So bulk density can be defined as total soil mass to total volume. It is generally in unit of gram per centimeter cube. Next definition, that is density index. It is denoted by ID. ID, that is capital I and in suffix capital D, that is ID is equal to E max minus E upon E max minus E minimum. Here we know E. E is void ratio of the soil. Now what is E max and what is E minimum? If your soil is in loosest form, there will be so many voids. So maximum void ratio will be there. So we can write E max as void ratio in the loosest form of soil. And E minimum, there is minimum void ratio, it is in densest form of soil. So E max and E minimum are this, and E, that is natural void ratio of soil. So we got all the definitions. Same way ID can be written as rho max in common and rho D minus rho minimum in bracket upon rho D common and rho max minus rho minimum. Now let us understand units. Now unit weight of water is 1 gram per centimeter cube, and if we want to write it in kilonewton per meter cube, it is 9.81 kilonewton per meter cube. It is generally taken as 10, not 9.81. Now let us understand last part of this video, that is hierarchy of unit weights. Now if we arrange unit weights in one hierarchy or one order, we can say that lowest unit weight of these all will be of submerged unit weight. Submerged unit weight will be of lowest value, and gamma D, that is more than submerged. That means dry unit weight will be greater than submerged. Same way bulk unit weight will be greater than dry unit weight, and saturated unit weight will be greater than bulk unit weight. So highest order will be of gamma sat. Gamma sat, that is saturated unit weight. So we understood all the fundamental definitions and basics of this chapter. Now you must remember all of these formulas considered in this video so that you can understand different relationships as well as numericals of this chapter. Here I will end my session. I hope you remember all the formulas. Thank you.